Hello, and welcome to today's ACM SIGSOFT webinar. This webcast is part of the ACM SIGSOFT's commitment to provide value to explorers and future learners. The ACM SIGSOFT webinar series features distinguished speakers over various topics in software engineering. I'm Tao Xie from the University of Illinois at Urbana-Champaign, and it's my pleasure to welcome you today. Before we get started, I would like to quickly mention a few housekeeping items shown on the slide in front of you. First, the slides will advance automatically throughout the event. On the bottom panel, you will find a number of additional widgets and resources. If you are experiencing problems with the slides or audio, press the F5 key in Windows Command R on the Mac or refresh your browser on mobile devices. Or you can close and relaunch the presentation. To control volume, adjust the master volume on your computer. If you have questions during this webinar, please type them into the Q&A box at any time during the webinar and click the Submit button. At the end of the presentation, we will have time to respond to questions. This section is being recorded and will be archived. You will receive an automatic notification when it becomes available. Today's presentation is Transferring Software Testing Tools to Practice, presented by Nikolai Tillmann, Judith Bishop, LIQUi, and Tao Xie. Nikolai Tillmann is the Principal Software Engineering Manager for the Tools for Software Engineers Group at Microsoft in Redmond, USA. Judith Bishop is the Director of Computer Science for Microsoft Research in Redmond, USA. LIQUi is a Senior Program Manager from the Developer Division at Microsoft India. Tao Xie is an Associate Professor in the Department of Computer Science at the University of Illinois, USA. Without further ado, Nikolai, please go ahead to start the presentation.
Thank you, Tao. So what we want to talk about today is a particular research project that started Microsoft Research and eventually led to the bootcamp in the studio. And so what we talk about is a particular way how to automate testing, in particular how to generate test cases. So to give an idea of what we mean by that, consider some code, for example, a function that classifies triangles given the length of the sides. This function can receive different kinds of inputs, here in the form of an array of integers, and it's supposed to return what kind of triangle the different side lengths represent. So the triangle could be equilateral, or scalene, or isosceles. So what you have to do in order to test it is you have to come up with different kinds of inputs, and you need to determine what the expected outcome is for each particular input. There are different approaches to test. The most obvious one is that some people study the specification of the problem and then carefully design test cases that are representative, picking particular inputs and defining what the expected outputs are. This is a very expensive approach, and it typically results in somewhat incomplete test suites since it's easy to overlook certain cases. Another approach is to automatically generate an exhaustive set of test cases. In some sense, it could be pairwise data generation, it could be enumerating all possible inputs, and combining that with a test oracle that can determine whether for any given input the computed outputs are correct. Again, this can be very expensive since it exhaustively enumerates values. So what we want to talk about today is a research project that automates the generation of test cases in a way that is similar to how a human would approach the problem, and it is not as expensive as brute force would do it. So to give you a bit of an idea of how this works, let's look at a particular piece of code. So on the left, there's a function coverMe. It takes an array of integers as input. It branches depending on the contents of the array. And in some cases, it can throw an exception, which might represent a bug. How do we generate test inputs for this code? So when you look at it, it's very intuitive to systematically go through all of the different cases in the code. And that's exactly what our automated tool does. So to get started, we run the code with the simplest possible input, which is, in the case of C# here, the null input, which represents an illegal array. Then we run the code, and we monitor instruction by instruction what happens. And in this case, the code is going to return because the input is null. We record this fact, and then next we want to trigger a different behavior of the code. So to do that, we look at the previously observed behavior. So previously we have seen that A was equal to null. That was true, which we also down here will represent in a tree structure. So we have seen the true case. We haven't seen yet the false case. So we're going to construct a constraint system representing the negation of a previously seen condition along the path that was executed. Then we invoke a constraint solver, which is able to determine inputs which satisfy this constraint system. And we use a very sophisticated constraint solver, Z3, developed also at Microsoft Research, which is really good at reasoning about different programming constraints, including constraints over the heap. So in this case, we would figure out that we need a proper array. And again, PAX tries to minimize inputs, so we would get the smallest possible array, the empty array. And with that input, we run the code again. And now the code will take a different path, skipping over the A equals null check, and advance to the next condition, whether A.length is greater than 0. And for our empty array, it is not the case that A.length is greater than 0. So we discover that, store it, and the next time around, we will want to take along a path we haven't seen yet. So we are going to negate this particular outcome, generate more test inputs, and so on. So this is a very systematic approach, how to enumerate all possible execution paths. And in case of a program that doesn't have loop or recursions, this will terminate after a finite number of steps. And then we know that we have generated a representative set of test inputs that cover all corner cases. If there are loops or recursions, then what we came up with are different heuristics to guide the search along execution paths that are more likely to increase code coverage. So it will terminate after some bounds are reached. So that is the approach. We did not invent the basic idea. It's been implemented in a number of different research tools. But when we came across it, we really believed in its power, and we wanted to make it into a tool that is usable by many, many people. So we did that a while ago at Microsoft Research. So our team developed a tool, we call it PAX, stands for Program Exploration. And for the first time, we put it out for people to use in 2008. And to give an idea how it looks like, so you can install it in Visual Studio, right-click on any code, and ask it to generate test cases. And then it generates a table similar to the one you have seen on the previous slide with inputs and outputs. And furthermore, these values can be persisted as traditional test cases. So PAX also generates code for unit tests that fix the input-output behavior observed during the exploration. So this is an end-to-end unit test generation story. So we released it in 2008, and we quickly got a huge number of downloads, at least when you look at research tools. So we had 30,000 downloads after 20 months. That is quite an achievement for a research tool. And we also had an active community pretty quickly, posting more than 1,000 posts discussing the technology and how exactly to use it. Then what happened next is that we discovered that every time somebody is trying to apply the tool on code, it's typically a challenge to unit test code. Some code has not been written with unit testing in mind, and the only way to test it is to write integration tests. So in order to make code unit testable, we designed a test isolation framework called Molds that we also released as a research tool a year later. And then this offshoot of the project became very, very popular because everyone who wants to do unit testing, whether with test automation or not, needs to isolate code. So this offshoot was picked up by Visual Studio and it shipped in 2012 as the FAKES framework. So it became a part of the Visual Studio product, not a separate research download. So this was our first big achievement to take the research ideas into production. And initially it was only available in a very premium edition of Visual Studio, and people voted to get it available more broadly, and then that also happened a bit later. Time went by, we kept iterating on PACS, and we will tell you a bit more about that in a moment. And then just very recently, in 2015, the entire PACS test generation product was picked up by Visual Studio and it shipped. Now it's called IntelliTest. So it's part of the Visual Studio Enterprise Edition in the box. It's no longer a separate research download. So again, we are very happy that we eventually succeeded, after many years, to get it shipped in Visual Studio. So what exactly happened during these years to take this research idea and convince the Visual Studio product group to include it and make it clear that there's a lot of value for our customers? Let's look at that in detail. So actually taking a step back first, there was something before PACS. We didn't immediately have the vision of how the test generation tool should look like, but it was instrumental to look at a previous project our team worked on. So before PACS, we worked on Spec Explorer, which is a model-based testing tool, and basically a model checker for certain .NET programs. So the idea is that if you have a self-contained C# program that is not allowed to interact at all with the environment, then we have basically a static analysis engine that can reason about the program and generate test cases. So it did not run on any real product, which typically has some environment tie-in, but you had to write consciously a model of the product that is self-contained. So instead of calling out over the network, you had to model all of the different network components in C# in a self-contained fashion. So, but then on the surface, it looked like Stack Explorer was exploring C# code, so why wouldn't it work on real code? And that's where the idea of PACS was born, applying it on real code, where we had to completely re-envision the infrastructure, the engine that it runs on. So instead of a static analysis, we figured out that it had to be a dynamic analysis running on the real platform. And we surrounded it with the idea of parameterized unit tests as a vehicle to engage that new engine. So instead of writing a closed model, we had the idea that the developer writes parameterized unit tests that model some aspects, and then it calls out to the real code that the PACS engine could explore. So that's how we arrived at the idea of PACS. And I already said, so on PACS, you still need to do some work to isolate the code from the environment where it actually matters for the test case generation problem. That resulted in Molds that shipped later as fakes. So we had to pivot here a bit in our vision. Then, while that shipped in 2012 as fakes in Visual Studio, we didn't quite achieve that level of maturity for the test generation engineers. So we looked at different ways how the experience could look like. We created a web-based experience called, first of all, Packs for Fun. And we found that a lot of developers were very happy to just copy and paste code into the web without having to install an add-in. So that helped us gather even more feedback. Then Tao Xie had a brilliant idea of how to turn it into a game, Code Hunt. You will hear more about that later. And again, that opened a whole new audience that could give us feedback and evangelize the technology. And after iterating and simplifying further, finally in 2015, it shipped as IntelliTest. So a lot of iterative refinement went in between. So an important aspect is landing your first customer. And so before we even went out with a research prototype, we tried to find groups in Microsoft to adopt our technology. And there's a typical chicken and the egg problem. Nobody wants to bet on you if you already have a customer. How do you escape that vicious cycle? Well, you have to go in and do all of the work for the first customer. So we identified the .NET Framework team and SharePoint, and we picked up some really hard testing problems they had, and we systematically tackled it. And that was very helpful in getting them as a customer. There are other challenges to overcome. Outside of Microsoft, licensing was a big issue. So initially, we only had an academic license, since PACS is a research tool, and we had to iterate over that. In general, doing many iterations is crucial to convince your first customers. Then, when we generate test cases, the way we envisioned the technology originally was in a very, very minimal sense. We want small test inputs, and part of that is that PACS prefers numbers that have no bit set. That is simpler than big numbers with many bit set. So one outcome of that was that when we generate strings, they tend to be filled with the 0 character, with the 0-bit pattern. So not the number 0, but the 0-bit pattern. This is the most natural value for the PACS engine, but it confuses people. So we adapted to that feedback, and there's extra logic in our constraint solver connection where we now generate human-readable characters instead of the more simple 0-bit pattern. We didn't expect that initially. Another human factor is naming of things. When PACS generates test cases, it just names them with numbers. So they have consecutive numbers, test case 0, 1, 2, 3, and so on. People have always written test cases, and they spend a lot of time naming them well. So we also added features to our tool to keep names that users like. And it didn't stop there. We experimented with many different visualizations, aggregating information under different topics. And some of these, over time, proved very, very useful. And others were experiments that were eventually discarded. So visualizations are important. Misconceptions is another problem. So when people hear test generation, they have certain ideas of what it means. Some people think that it automates everything around testing. But just because we are driving vehicles that are called automobiles, it doesn't mean that you don't have to know how to drive. We are 100 years in, and there's still research going on how to automate the actual driving, but that hasn't been done. So similar for our test generation tool, you still need to know how to use it, and it's important to communicate that. Similarly, some people expected to find really, really deep issues out of the box, but that is not what PACS can achieve. PACS is very good at finding, in IntelliTest, at finding null reference exceptions. And unlike static analysis tools, all of these issues that IntelliTest finds are real. But still, people would rather see some really, really deep business logic flaw. But the truth is that unless people write assertions or encode somehow what properties they're interested in, this is a part that cannot be fully automated. So again, you have to be careful in how to message it do not oversell what the product does. Some people have adopted workflows, and they feel threatened by a tool that doesn't seem to fit in existing workflows. For example, test-driven development. What does that mean when the testing part gets automated? And I think that's actually a very nice story here. But at first, people feel sometimes threatened that their existing workflows have to change. So that has to be properly communicated. In general, when people have problems using your technology, it's not their fault. Either the technology got it wrong, or the way it communicates with the customer is not right. So that is an approach or a philosophy one has to embrace. The customer is right, either the technology or our communication that is wrong. So we went through many, many different feedback cycles to improve and retarget. So in the very beginning, before we had the molds framework, when people tried PEX and they hit some piece of code that unconditionally calls to a different component over the network, which causes problems for unit testing, we told them to refactor their code, introduce interfaces. But asking people to change their code or the way they work is very, very difficult. And that's why we started developing the molds framework to have a way to easily isolate code. So again, the reason we developed molds was because we really, really listened carefully to the feedback from our customers. And at this point, I would like to hand over to Pratap, who will talk more about the journey of PEX from a research tool to a Visual Studio feature.
Thank you, Nikolai. Let me now present the product group's point of view. PEX is a complex tool. So how do you productize and integrate this into an IDE like Visual Studio? First, we had to establish alignment, the vision of VS, Visual Studio, and answer questions like, why is this important for VS? What is the problem that the tool is trying to solve? For whom is it trying to solve it? Is it for greenfield code? Is it for brownfield code? What assumptions about the code does the tool make? That the code is well isolated from external dependencies? What is the expected prerequisite level of skill from the user that the tool expects? How do we even know that it indeed solves such users' problems? What feedback data do we have to substantiate the claim? Why should we as a product group solve it? Why not leave it to the ecosystem? After all, Visual Studio has a flourishing ecosystem of plugins. Why not leave it to the ecosystem to solve the problem? Then comes the part of selling the idea within the organization. There are many constituencies involved here. The dev team, the management, the product marketing team, the sales and field team, and even legal, especially for tools like PEX, which use components like the Z3 solver, which have been on GitHub for quite some time now. Each of these constituencies come into play at different stages of the product cycle, and therefore it is imperative to take them along in the journey. To procure funding, it is essential to be able to show a stream of value as opposed to some single big bang value after a 3-year release cycle. So we had to identify a layered set of core scenarios that could be shipped and validated progressively. Each layer in this progression leads the user to deeper and deeper interaction with the tool until the point where he is fully engaged. So we came up with Explore, which is very similar to the code digger experience where the user wants to know about the input-output behavior of a piece of well-isolated code. Then we had Persist, where he proceeds to save the generated tests for use as a regression suite. Then we came up with Assist, where for more complex code, the user is able to deal with the warnings raised by the tool. And finally, to Specify, where the user now writes PUTs or parameterized unit tests. This is a sophisticated user, one whose understanding of the code under test has grown beyond what can be represented by a few individual example test cases. And then there was the user interface. Not only the look and feel of the various windows, but also about usability, about naming and branding, and even about how the generated test code looks different from handwritten test cases. For example, the test project generated by PEX has a different name. The unit tests generated by PEX have a different name. Unit tests generated by PEX have a lot of custom attributes on them. Sometimes they even have more code in them. And the unit tests generated by PEX have different formatting of the code within the body of the test. And PEX introduced parameterized unit tests as an additional artifact, and so on. So I mentioned about getting feedback and data. Here are the channels we used. So we made early drops of PEX available as a plugin for Visual Studio 2013, both of PEX and of CodeDigger. The Visual Studio MVP community is a very important resource for us who give us very early and candid feedback. We got feedback from internal dogfooding by teams within Microsoft, as Nikolai mentioned a little earlier. User voice is a very important channel that we use. Here, external users can file ideas, vote for them, and then we pick ideas from there on what to implement next. Stack Overflow is a forum that we have set up where questions can be tagged with PEX or IntelliTest, and where we go ahead and answer as soon as we can. This is a very active and thriving forum. We also have Facebook and Twitter presence, where periodically there are posts from folks in the team. So based on the feedback, we made some important additions and some equally important scoping calls. We externalized the support for third-party test frameworks. The implementations for NUnit and XUnit are now external and open sourced. This significantly increased the reach of the tool and allowed the community to be invested in its success. There were also some important scoping calls. VB support was scoped out. We heard from our users that they do not want a tool to ever make changes to their code. Thus, the fix-it feature was scoped out. Usage of code contracts was low amongst our user base. The PEX Explorer window is useful if you run PEX on a whole bunch of methods at a time. Our users did not use PEX in that manner, so we scoped that out. And the same with reporting and with the tools options hive in VS. So this last mile from research to productization was all about moving the engineering to our team here in India, about establishing a community, getting early feedback, and simplifying and streamlining the core set of scenarios. Here is what we shipped as part of VS 2015 RTM, fully integrated into the Visual Studio IDE. That externalization I mentioned earlier, that led to a very healthy number of downloads. The extensions now have for NUnit 13,000 plus downloads and for XUnit 8,500 plus downloads. And the overall feedback, as you can see, has been very encouraging. So there you have it, productization in a nutshell. Next, Tao will talk about collaboration with academia.
Thank you, Pratap. Next, I'm going to talk about collaboration with academia and outreach to the broader research communities for producing research impacts besides practice impacts. We could see collaboration between industry and academia would be a win-win collaboration. From the industry lab's point of view, besides focusing on important, urgent tasks for making these tools usable and practical, they could also engage collaboration with academia for focusing on longer-term research innovations so that we could prepare for the future, further many years, in the future for further improvement of the current tool. Of course, collaboration with academia could allow the industry lab to have more manpower to together produce a research impact besides practice impact. From the research, the university point of view, industry labs could provide a powerful infrastructure or tool like PACS available to the academia to further build some more advances and extensions for research innovations. Because many academic prototypes out there may not be powerful enough to tackle the complexity of the real-world code bases. In addition, collaboration with the industry labs could allow academia to focus their efforts on relevant, important problems, either near-term or longer-term in practice. So together with industry labs, academia could produce both industry and research impacts. In terms of the specific forms of the collaborations, one natural form is to host academic visitors in industry labs. For example, for myself, I spent several summers as a consulting researcher visiting the PACS group for carrying out some collaborations. Back in 2008, in collaboration with the PACS team at Microsoft Research, I developed these fitness search strategies for improving the effectiveness of PACS, and later on that year, fitness was integrated into the PACS search engine being released to the public, and later on, to the product. And then later, by 2010 summer, I worked with the PACS team together. We came up with a coding tool idea. Later on, we'll briefly talk about. Of course, another way for engaging students to carry out collaborations is to have student internships in research labs. Besides hosting academic visitors in research labs, a lot of collaboration could be also conducted in academia, or like external extension of PACS or leveraging PACS in research can be also conducted by researchers in academia independently, not necessarily needing to collaborate with the PACS team. So we have a mixture of such excellent examples of leveraging the PACS infrastructure or being inspired by a lot of problems being discovered when applying PACS on some real-world code basis. One kind of academic research would be like conducted for inspiring internal technology development inside the PACS team. For example, like some research being conducted at academia on dealing with complex regular expressions actually later on inspires an internal development of some more advanced conjoint solvers to deal with complex string constraints. Some other kind of academic research would be exploring long-term research frontiers. As an example, like dynamic invariant inference is a long-term interest for the academic communities. And the PACS team collaborated with academia in extending the PACS infrastructure to deal with like a more effective inference of these invariants called like DiSci. DiSci actually was released as open source and being used by broader academic communities for further extension of the PACS interface. Some other academic research would be like on addressing some immediate problems faced by tools like PACS. There are some different efforts on exploring effective method sequence generation, along with dealing with those difficulties faced by developers when applying PACS. Some examples like Kavana and SEVs. And more recently, also has some efforts like this year in ICSI 2016. There was a research paper published on combining PACS and co-contracts. So let me get back to the coding rules idea that I came up with during my visit at the PACS scene during 2010. So basically, initially, the PACS scene put PACS online as a website, so that you go to the website called PACS for Fun. You could quickly play with PACS to see how PACS could generate tests to cover different portions of the code that you type in the browser without any installation of specific, IDE or the PACS itself. So during the summer of 2010, and I came up with the idea of these coding do games to make the website more fun, to really engage users who use PACS along with training their skills. Let me briefly tell you about the ideas of the coding rules. Basically, as a game creator of a coding rules, you create a secret implementation, as you could see on the slide, the left-hand side. As you could see, this secret code puzzle method with one argument as x integer and then return another integer. Right? Inside the implementation, it's just a simple recursion, or you could rewrite it as a loop. So then you release a player implementation on the right-hand side to the user. The user could see the player implementation but cannot see the secret implementation. The player can win the game if the player could modify the player implementation on the right-hand side to match the input-output behavior of the secret implementation. As you can imagine, without any help, players cannot really accomplish the goal without knowing exactly what the code or what the behavior is about. Here comes PACS. After the player click the button like capture code in Kohan, which Judith will talk about very soon, then PACS in the back end will relate the secret code and the player code together, and we generate test inputs to excise different portions of these two pieces of code. And then we give you feedback like the being shown in the table near the bottom of the slide. As you can see, for the first two rows, basically they are passing tests, indicating that the secret code and the player code produce the same return values when given the input value 1 and 2. However, if the input is 3, the player's code will produce 3 naturally because just return x, but the secret code returns 6. Based on limited data points to indicate consistent or inconsistent behaviors, players could further modify the player code to more and trial and errors and generalize to infer the behavior of the secret code. Okay. So next, Judith will tell you more about how we could take this coding rules idea to a broader usage in the education setting.
Thanks, Tao. So once PACS for Fun, as it was called, took off, and we were getting hundreds of thousands of users worldwide who were using this game to just play and work on coding, we decided that it would be a good idea to make it more fancy. And the goal there was to actually utilize the data to make sure that we could have, as actually Pratap has also said, a much better experience for users. And there were two ways that we wanted to do this. We wanted to have it look more fancy, so we skinned it in a very nice way. And we also wanted to add as a second language to the experience Java, because many students out in the world at that time were mainly using Java. So Code Hunt now, and you can go and play it right now while we're talking, it's at www.codehunt.com. It's a powerful and versatile, serious coding game. It's got PEX as its underlying engine, and we have discovered through surveys that we run that it's used by students, by developers, and also by researchers. We keep all data about the way in which people use the game in the cloud, and of course, it's available as open source. About that. Now, in order to make this popular, we also promoted it through contests. So it isn't just out there as a game that people play daily. We launched through a period of 20 months a series of contests, and these were run either worldwide or specifically in countries where they wanted them. We discovered that students really enjoy these games, and it adds to their retention. And discovery is a powerful driver, enabling them to direct what they're going to do next. So let's go on to what it actually looks like. This is a similar example to the one that Tao has already shown you. So there is a SIGSOFT program at the back. We have to write those. So these are what we call puzzles. And for every one of these puzzles, and we've got over 400 of them now, of a variety of difficulty levels, we write those. And they're put together in groups for contests. Otherwise, there's a basic set of 127 which are available on the main site. And people use them. It's a wonderful game because it's completely watertight. There can be no cheating. You can only win if you get the same answers at the end. Of course, it's not syntactically the same, and that's the beauty of PEX. It's semantically the same. So there could be a huge variety of actual answers which achieve the same results. There's a clear winning criterion, and we base that basically on how many bytes of code are done. And then you can see at the bottom there of the slide that users get a skill rating of 1, 2, or 3. So if your code is very poor, you only get a skill rating of 1, and so your score in the overall game is not as high as if you had a very good program. Now, what happened was, once we had this launched, we found that it really appealed, and people were using it all over the world. In any 1 year, we had this pie chart at the bottom showed that we had over 337 sessions running in 1 year. It was very sticky. People came back to it day after day after day, the same users. It was used in every country that we could think of. And we have over 1,000 users a day still at the moment. We are trying to get Python going. That hasn't happened yet. We'd be happy to have collaborators to help us with that. This is what it looks like on the outside. So you get that first splash screen, and then you select sectors. For example, these sectors are labeled according to types of of programming features, and then within each feature you get different levels that you have to pass. In a contest, it's not like that. They're labeled differently. And this is what one of the levels would look like. And as you can see, it's a little bit more colorful than the one that Tao was showing earlier. And at the top, there are various buttons that you can press to go forward and back and become familiar and reset your level, switch to Java, and so on. And when you're finished, you get this very nice splash screen that you've captured the code. Now, moving on to what really happened to us is in 2014, we had an aha moment. We ran a very nice competition with our colleagues in China, where they had close on 2,500 players entering a contest. And on average, the students were taking 41 tries per puzzle or per level to solve. So they would batter out against these things until they'd solved them. But then we looked at the top 350 players, and we found that they only took 7 tries. And so we realized that this was a game that could identify top coders through this method. And so this is lesson 6 in this webinar, that what we're doing is we're following the data, and we're following the data in 3 ways. First of all, the Java is provided by a source-to-source translator. So we do not have a Java compiler inside the Code Hunt system. We take any Java program and we convert it to C#. And similarly to what Prakap said, we looked at the data and we said, well, which are the features that people are using the most online, day to day? And we concentrated on those and made sure that those were properly done and that there were no bugs in those. And we concentrated our efforts on those. Secondly, and this was a very important one, of the puzzles that we had, we subjectively rated them by difficulty level between 1 and 5. But then as they were used, we discovered that our subjective guesses as to difficulty could be adjusted depending on how people actually reacted to these puzzles. And so by crowdsourcing the user attempts, we would change the difficulty level so that when we used that puzzle again, it was inserted into the right part of a contest. And then thirdly, this vast number of attempts was very valuable data, and we managed to open source it. And so we've got 13,000 programs which are now on an open repository on GitHub, and they represent the attempts of 257 users, which were done over a period of a weekend. And so it's a consistent level of how people actually attempt to solve 24 puzzles. A very interesting data for people to look at and use in research. And now I'm going to hand over to Nikolai to summarize what we've said.
Thank you, Judith. So we covered how PEC started as a research project with one clear vision of how to explore real code and generate test cases. Or we took that vision, pivoted on it, created new scenarios around it, a whole test isolation framework, a web-based experience together with the game aspect, and how all of that eventually led to PEC become a feature in Visual Studio. We talked about how it's important to get your first customer, and even if that means going all the way and doing the work to integrate with that first customer. Don't underestimate human factors. Just because you have a particular vision doesn't mean that other people see it in exactly the same way. They might have different conceptions of what it means. So you have to keep embracing feedback and keep iterating on the product. We found it very valuable to collaborate closely with academia, get new insights and feedback as well from students who are great at trying out new ideas and really pushing the boundaries. We heard about the impact beyond testing, how it actually helps in education by leveraging the game idea to motivate people to improve their programming skills. And we are really happy to use a lot of data that we gather on the website to drive that forward. And with that, I would like to lead over to the questions and answers session, part of the session. And let's see what questions we got.
Thank you. For the audience out there, please type in and submit your questions, and we will watch out on the questions and then pick those for our presenters to answer. Okay. Okay, the first question is, could you tell us use extend and the use increase momentum of IntelliTest in Visual Studio? Probably Pratap, maybe you could say a few words from the user of Visual Studio point of view.
So let me just say that we are very excited to see a steady month-over-month growth in our user base. So that growth is very healthy and it has been very steady. So I'm not in a position to reveal exact numbers, but I can definitely say that the numbers are quite healthy.
Thank you. So one question is for Judith. Like the earlier Pack for Fun and Kohans, along with other great projects like TouchDevelop for Microsoft Research. So what are the motivations, incentives for Microsoft Research to invest efforts on such educational efforts?
It's not initially that we are investing in education as much as the exact opposite, and that is that education is such a fertile field for research. There are so many unexplored and unsolved problems in education these days, and there will continue to be on and on. Technology has a great place to play. Everybody is trying to automate programming to assist with automatic grading in particular is one of the great fields. And when we attended a big conference on education in 2014, Code Hunt was presented there, and people were very excited about it because the idea of this automatic grading, which Code Hunt does provide, was considered to be great. Code Hunt stopped short of an experience which we would call a course experience. In other words, we can't easily set up a set of problems which would be easily used by a course. We can do it, but it's not as slick as some of the other systems. If we could extend the system, if we had more resources and more incentive to do this, or more collaborators with academia, which of course is one of the themes of this talk, then we could do it. And it's certainly possible that we could extend the system so that a professor could enter a set of problems relevant to what they're currently working on, students, and out would pop how well each student is doing at any one time, and in fact even more, because they would be able to find out what difficulties they're having at what stages and with which features of programming.
Okay, thank you. I actually seen a couple of questions related to Java. Okay, So as Judith mentioned, Java has been supported in the Kohan environment. Is there any plan for extending PEX to the Java IDE to support Java software development?
So in Kohan, Java is supported by a translation to C# internally, which works great for the game experience and the kind of code that has to be written for playing in the game. In order to support Java as a first-class citizen, it will basically amount of creating an entirely new engine. Java has a different instruction set, a different virtual runtime. So our team is not planning to tackle that issue. There are other research projects going on to create the same kind of test generation experience for Java, but I cannot really comment on the maturity of any of those.
Okay, next question is on modes and fakes. One question is on could you tell us a little bit about how, do you have some observed impact on fakes or earlier modes on improving productivity of developers and the code quality?
So modes is adopted as a test isolation framework enabling unit testing. I don't think we are tracking concrete metrics to assess what that really means in terms of code quality and speed of development. I think just the fact that people are adopting it speaks for that they see value in it. But that's a very interesting question and a challenge how to measure that.
Right. So Judith, one question is do you plan to support C++ in Kohan? Many people are looking for more and more language. I think that's natural.
As just following on from the answer that Nikolai has given, one must understand that the underlying engine is working in a .NET bytecode here. So on top is C#, and then any language that we can translate by source translation, we could do. And Java was the really easy one. As I say, we do have a Python translator. The work just got stalled. It should be able to happen if we were to release that. For the kinds of problems that Code Hunt deals with, I actually think C++ would be possible. But we haven't had a great call, for instance. Most people are happy to work in C#.
Yeah, and I think Python is the next on the list that people actually request for.
Yes, Python is the popular one in education at the moment rather than C++.
So next question probably is for Pratap. The question is about the usage of a source code coverage tool in IDE, like Visual Studio. So, I mean, code coverage tool is important to be used together with test generation tool or manual testing. Could you tell us a little bit about that?
So I'm sorry, can you repeat the question?
So one question is on the source code coverage measurement tool in popular IDEs like Visual Studio. So could you tell us what kind of code coverage tool would be supported or available to be used, together with IntelliTest?
So with Visual Studio itself comes with a code coverage tool. And as you would have already seen, the tests that PEX generates are just traditional unit tests. So any of the existing code coverage tools, including the one that ships with VS or any from third parties, can be used directly on tests generated by PEX.
Okay, thank you.
And maybe one more word on that. So PEX can be configured to aim for different code coverage notions. So PEX can try to achieve statement coverage or branch coverage. And if you go in and specify a bit more in detail. PACS can also generate MC/DC coverage. So you can visualize code coverage using different tools, as Pratap said, and you can also ask PACS to generate with different coverage goals in mind.
Okay, thank you. I'm afraid we have run out of time today. I would thank our speakers again for their informative presentation and insightful answers to the many questions. Special thanks to each of you for taking the time to attend and participate in today's webinar. The webinar was recorded and will be available online in a few days at the URL being shown on the site. And you can find announcements on upcoming ACM and ACM SIGSOFT webinars and other ACM activities at the ACM website and the SIGSOFT website. On behalf of SIGSOFT, the speakers and myself, thanks again for joining us, and I hope you will join us again in the future. This concludes today's webinar.